All right. So this is our lesson on probability. And so the basic, most simple definition that I'm going to give is the probability is the likelihood that something is going to happen. So it's just, you're just trying to predict. No, that's fine, Noah. You're just trying to predict the likelihood that something will happen. So it's typically set up like this, where you have the wanted outcome over the total possible outcomes. So it's a fractional setup to start, and you just are having your wanted outcome divided by your total possible outcomes. And then if we want to shorten it up, it's just easier to remember wanted over total. That's just a nice, easy way to remember it. Wanted over total. And this is how every probability is set up. You want your wanted outcome over your total possible outcomes. So here's this here. So if there's three ways really that you can kind of express probabilities. There's actually four. So the first is your fraction. So let's say we're looking at the probability of rolling a 3 on a dice. Technically, it's supposed to be called a die. Like if there's just one, it's a die. But I call it a dice still, just because that's kind of how I remember it. So the probability of rolling a 3 on a dice. So you're going to start off with the fraction of it. So the fraction is going to be, there's 1 3 on a dice, and then there's 6 other possibilities. There's 1, 2, 3, 4, 5, or 6. So we have a probability, our wanted outcome of a 3. There's only 1 3, and then there's 6 possible outcomes. So that's the fractional setup. And then if you want to get that to a decimal, you just punch 1 divided by 6 into your calculator, and that's going to give you, so you just divide it on your calculator. That's going to give you the decimal format, which is 0.167. And then to get it to a percentage format, you just times that decimal by 100, and that's going to give you 16.7% chance. So that's going to just, if you're expressing the probability of rolling a 3 on a dice, your theoretical probability is a 1 out of 6, 0.167, or a 16.7% chance. Let's go take a look at what that looks like in Desmos real quick. So probability of rolling a 3, you're just going to set it up 1 out of 6 and see there's that point, that's 0.667, the 167. And then you can times that by 100, and that gives you your percentage. So there's 3 ways. It's either 1 out of 6, 0.167, or 16.7% chance. Whatever you express it is more. I always like percentages and decimals personally, but that's how the 3 ways you can express it. And so in this probability, there's 2 main types of probability. Okay. And this will be on your quiz questions. There's the two types. Two types of probability. The first is theoretical. So theoretical is just the mathematical odds. So that's what we were doing right there, the odds of rolling a 6. Mathematical odds of something happening. So that's just theoretical. So if you're trying to predict, that's what theoretical is. And then there's experimental. And that's what actually happened. All right, so theoretical, just think, a good way to think of theoretical is predicting. So in theoretical probability, you're predicting And let's make that like we'll make theoretical probability blue, make it a little darker blue, and we'll make experimental green, because that, and then experimental, you're thinking reality. So theoretical is you're just trying to predict the odds. So if like you're at a casino and you're trying to predict what the next card is that's drawn, that's theoretical probability. Like if you run all the math and you're like, okay, I got a 10% chance or a 50% chance of a king coming up, but then a queen flips up. So your theoretical probability is you're predicting a king is popping up, but then the experimental would be a queen actually is what was drawn. So that's just the two ways to really think about it. And I'm not going to go too much more in depth because it really is not. I'm not. Sometimes you can overcomplicate stuff. The two differences are that's all it is. Okay, thanks for letting me know, Austin. That theoretical is just the predicting using the mathematical odds of something happening, and then the experimental probability is what actually happened, and it's as simple as that. So in this class for this unit, most of the time what we're going to be doing is trying to predict theoretical probabilities. And so theoretical probabilities, that doesn't mean that's exactly what will happen, but that's just giving you what the mathematical odds are. Most of the time it does not actually go as that is. But the thing is, the more that you do it, like the more rolls of a dice you have, the more it will match the experimental, will match the theoretical. So that's kind of what we talked about with the bell curve. So just think about it like this. Law of large numbers. What that essentially means is the more experiments or the more, I'm not good at spelling, and rely on the spell check. More experiments you do, the closer the outcomes will match the theoretical probability. So this is what the law of large numbers is. We'll talk about this more in a later lesson, but law of large numbers is essentially saying that the more experiments you do, the closer the outcomes match the theoretical probability. And so let's say we're trying to predict the probability of rolling a less, or let's say probability of flipping a heads on a coin, right? So that's a pretty basic probability. So let's just see if we got a heads. We'll just make a coin here. We'll say this is a heads. And we'll make this no fill. Got a question here. 50-50. Yeah, no, you're completely right. The probability is just 50-50. So probability of rolling a heads on a coin or flipping a heads on a coin. So we got our heads, and then let's make a tails here. We want not the head, we want like an eagle is usually on the back. So we got our heads and our tails. All right. So probability of flipping a heads on a coin. So we really have our outcomes. Remember, we first draw our thing here, right here, and we on top, we have our wanted outcomes. We'll make that a little bit bigger. Over our total possible. So our wanted outcomes is we want a heads. So that's a 1. And the total possible is that we have a head and a tails. So there's only 2 possibilities. So there's a 1 out of 2 chance of flipping a heads on a coin. And then if you do that in Desmos, if you divide 1 divided by 2, the decimal is going to be 0.50, or in percentage, that's going to be 50%. So 3 ways: fractional, decimal, percentage. And so this is what the law of, it seems pretty basic, right? But let's say that you're doing this experiment. Let's make these a little bit smaller to give us some more room here. So let's say you flip 10 heads, or you flip a coin 10 times. So you do 10 flips. And so the thing about this is that the experimental probability would be when you do the 10 flips. So let's say you do 10 and you go heads, heads. Actually, I'm just going to write them out for time's sake. So let's say you go heads, tails, tails, heads, tails, 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 heads, tails. So we got 1, 2, 3 out of 10 were heads. So our experimental would be right here. Our experimental would be 3 out of 10 off after 10 flips. Let me center this. And we got 3 out of 10 on when we actually flipped it, which is going to be 0.30 on a decimal, which is going to be 50% or 30%. So our experimental probability did not match up with our theoretical with 10 flips. But what the law of large numbers is, if we did 100,000 flips, it would probably be close to, 0.49 or 0.51. So it'd be maybe a percentage or 2 off, but it would get closer and closer. And then if we did 1,000,000 flips, or maybe let's say 100,000 would be 0.48 or 0.52. So it's like 2% off from the theoretical. But if we did 1,000,000, it would just get closer and closer to 0.49 or 0.51. And then, if we did 1,000,000,000, eventually, the more flips you do, eventually it will get to the theoretical probability. So that's what the law of large numbers is. So let's do some compound probability, and that's when there's more than one